Hi everyone, welcome back to the workshop, and we're on to another repair video here. This time it's a Fluke 51 Mark II digital thermometer that I've purchased off of eBay here in the UK. Saw the picture online looking for some faulty test gear that I could perhaps get my hands on to do a repair, and I saw this one obviously missing the keypad here. I thought, I wonder if that's something I could get my hands on and maybe make a repair job of it. So I went ahead and purchased it. The guy that bought it from actually acknowledged that he watches a few of my videos, so that was great. So here it is, arrived all safe and sound. It actually comes with the holster there, and obviously the unit itself, and I do actually have the back cover for it as well. So at the moment the only thing that seems to be missing is the actual rubberized keypad, the module that goes inside the unit there. Now, before I actually purchased it off of eBay, I actually went fishing to see if I could get my hands on a replacement keypad, and I really couldn't find one anywhere, certainly not in the UK. I did actually find one online on ebay.com over there in the States, and I have actually gone ahead and purchased it. I had to get a friend in the States to buy it for me because the seller wouldn't ship outside the US and all the rest of it. So I do actually have it on its way, but the original intention for buying this unit was to actually go and try and retrofit my own keypad to interface it to the electronics and get it up and running that way. So I'm still going to go ahead and do that, so let's have a look and see what we've got. So opening the unit up, obviously this is where the back of the keypad module will sit, and there is actually an elastomer strip there. Looks like there's not a circuit board on the back of the switches as such. It's just a membrane itself that's got a little flat flex sort of arrangement that will go up and under and be sandwiched between that strip there and the PCB itself. So you can actually see there's a row of vias along there under that sticker there. That's actually the back side of those contacts there, so I might be able to do something there. So the idea was that I would go ahead and make my own keypad. There's a few problems I'm going to come across. The battery compartment here, as you can see, is actually quite deep, actually sits in here. That's why there's not really a PCB in the back of here, because there isn't that much space. The keypad membrane is actually quite thin, obviously to make way for the back of the battery compartment. And there's a couple of, let's see if you can see that there. If I hold it at this angle, you can see that the screws that hold the two halves together there, you can see them there, and they actually mate up with these two protruded studs there, and as you can see, they're not really that high, so that battery compartment's actually going to sit down flush with the top of those there, so anything that I build has to be underneath that. So let me bring in some parts. I've already sort of made a start at this as I sort of throwing some ideas around as how I'm going to tackle this. So let me bring in some parts. So I thought, first things first, I need to make my own buttons. I'm not going to be able to make my own rubberized keypad. So I thought next best thing is I've got a laser cutter, so I've actually gone ahead and laser cut some 5mm acrylic there to the dimensions of the holes there. I'll just put one in place if I can get through, and the idea is that it'll sit proud there, and then somehow or other I'll be able to attach the back of that new button to a small micro switch or something like that, and I'll do the same for them all. Now obviously I need to mount the switches in place, so the idea I had for that is I've actually cut a bit of vero board here, and that'll actually sit in there. Now the way I've cut it, it sits flat on the bottom of the rear of the front panel there, such that the top of the vero board there is flush with the top of those studs there, and that means that that vero board's low enough now that the two halves still clamp together perfectly. You know, there's no gaps or anything like that. So therefore, anything I build in terms of putting micro switches on the board will obviously have to go on the underside, i.e. everything will need to be mounted on this side here. Now there's not a lot of room. I think if I hold it at that angle there, you can see the top of that stud there, and there's not really a lot of room between there and the where the buttons sit. But I think there's just enough room. I've found a bunch of micro switches from my own stock here that I think will fit the bill. So these switches here come with a couple of long legs on them, but the good thing about them is, I'm not sure if you can see it on camera, I think they're designed that you can actually bend these right over and they'll go, you know, below the height of the back of that switch, because you know the way they're shaped is there's kind of like a little recess, so that when you fold them over they'll sit in that recess. It means that the profile of the switch is actually kept to its bare minimum there. So I've gone ahead and done it with one of them, as you can see there. Let me just turn that one round, and you can see there it's bent over and it's still, you know, below the level of the back of the switch. So the idea is there, I've kind of put some black dots where the center of the push buttons will be. So the idea is that I can maybe mount that switch there and do the same with the other ones, and then I just need to wire them up. And of course I'll need to find some way of actually attaching this acrylic here to the actual you know, the switch itself. Maybe, I don't know whether I can super glue that or whatever. I'll have to see what I can do there. Now, as there isn't a lot of room in terms of height here, I can't really you know, we'll just wire it up with any old wire. So I'm going to use some of my thin prototyping wire, wire wrapping wire, and that should just keep, you know, I should be able to wire it all up, and it shouldn't protrude too much, and should still allow this Vero board to sit in as far as, you know, into the case as possible. So of course the next problem is, what's the I/O like, and how are the original switches wired up? Well, it just so happens, if I zoom out a bit, that the eBay ad that I bought the keypad module from, and here it is here, they actually had a couple of photographs on that ad here. Obviously one showing which switch is which, and you can see, I don't know if you can see that, but there's the little strip there that will be sandwiched by the elastomer strip on the unit. But luckily they actually gave us a photograph of the back side, or well, actually it's the front side really, of the keypad membrane, and I think I can trace out this here and determine which pin is what on the strip here, and I can obviously create a little diagram of myself from a new switch arrangement. So the next thing to do is to mount the switches on here. I can probably solder the switches in place using some of the pads on the Vero board there, and get them all into the position that they need to, and then I'll start looking at creating a circuit diagram. Alright, jump forward a couple of hours. I've made a little bit of progress. As you can see, I've got the Vero board in place there, and if I just turn it over slowly and zoom in, you can see that I've wired up the switches and made myself a little wee header here and jumper links across to the back of the PCB there. Luckily there's some through-hole vias on the back of the board there, which I was able to solder to, and which directly correlate down onto the elastomer strip there, so the contacts are actually underneath, so it was easy just to solder onto the top there to make the contacts. So I've kind of rigged it up here for testing. I've not got the Vero board in place there, but it's good enough for testing, and I've wired up power to the batteries and the back of the unit there across the terminals there, and I've got it powered up. Now the first time I powered it up, some of the segments weren't working in the LCD, so I had to remove it all, and it's basically just these strips, the normal elastomer strips you can see down in there either side of the glass there. Just needed a bit of a clean with some alcohol, and it seems to have come up. So again, going back to the diagram here, This is the one that I got from the eBay seller here, so I managed to trace this out. Wasn't quite as easy as I thought it would be. When you've got ones like this up here, it's obvious that's the two contacts there going away up onto there, but some of them have the likes of, like this one here, it's actually got 3 tracks sort of thing going onto the pad there. Now, one of them's going to be the track coming off of one side, and then the other 2 could possibly be connected together on the other side, or 2 of them are going on the top side. So in other words, it wasn't easy to see exactly which ones were connected together, so I've kind of made a guess, like in this case here, that what I've called 4, 5 and 6, I think 4 and 5 are connected together. And the reason I've come up with that is because if you look at this one going down here, it's looks like this track here is coming on to this top side as we look at it, because the track here comes very, very close to the pad here. So I think this one here is connected to this top side, and these 2 I think are connected, both of them, to the other side, because there seems to be a bit of a gap there. So I think they're going to the other side, and they'll obviously be connected together because of that. So it's the same for the likes of this one, this one, this one, this one, this one. So a lot of scope for error if I get it wrong, and obviously the push buttons won't work properly, but I've kind of done the best I can. And what I ended up doing was creating a little diagram here, just zoom out a bit there, of the rear view as I look at it, i.e. this view here of how I think it's wired. Now some of these switches here I've X'd off there because I don't actually have them. This keypad here is for a slightly different model to the one that I've got, so I didn't really need those ones there. So back to the actual unit itself, and if you look at it, if I turn it over, try and be a bit careful here, don't break the wires. So if I press this switch here, is actually the power switch there, so if I just press it, we've got power. In fact, I think I'll plug in the thermocouple up the top here. I'll get the right way round. I'll just power it up again. Need a bit of force in the back of the board there, because the case actually presses down on here, so a little bit of force there to help with that. Not sure why it's reading so high. I hope it's not a faulty board after all this. It's probably because my fingers, yeah it is, it's because my fingers are on the back of the board there, obviously upsetting the circuit there. So if I press some of the other buttons here, there's this one here is the backlighting. I'll just, you can, don't know if you can see that, but the backlighting did come on there. And some of the other buttons, I think this one here is for degrees C and Fahrenheit, etc. Yeah, that one seems to be doing so far so good. I don't exactly know what some of the other switches do. I don't know what setup's meant to do, enter, up down controls. I'm not really sure what they're supposed to do, but I need to look into that and probably download the manual for it and see how they're going to go. So I think the next thing to do, if I just switch it off now, yeah, that's it switched off. I think the next thing to do is actually get the Vero board in place there. I'll move it into place and maybe try it for size with the actual acrylic that I cut there for the actual buttons themselves. So I'll wait and do that now. Actually, here's a little interim shot before I actually try the acrylic for size. I've just bolted it together now, and you can see the switches through the holes there, and then obviously the power switch here, and it does actually power up. Everything seems to be working there. So yeah, I think the next thing to do is the acrylic. So I've got a little bit of filing to do. Some of these acrylics are a little bit big. You know, the idea is that they'll just sit in there like that there, and that's obviously my push button here. You can hear it clicking there. Actually it's upside down, it's because they're slightly tapered the way the laser has actually cut them, so it actually needs to go that way around there. They might sit a little bit high, some of them, because the actual switches themselves are actually closer to this top surface than what I anticipated they are. You know, you can sort of see them there, especially this one round about here. It's actually very close to the top. Some of them have more headroom than others. You know, this one here got a bit more, but I'll just have to live with that. I'm not going to bother trying to cut down different heights of acrylic there. This is just 5mm that I've done across the board. So and I think the idea is possibly a spot of glue there. I'm not going to use super glue because there's a chance it could seep down the side of the button there and into the contact, and that would just ruin my day. So I might, I'm not sure what I'll do. I don't know if sealant's a good job or not. I'll probably use epoxy, something that's, it'll should set quite good, and that'll hold that. Ideally I'd maybe have a little wee hole on the back of the acrylic there, you know, just to locate the button a bit better, but I think that's a little bit impossible to do. Could possibly have done that with a laser, but a little bit too much trouble there. So I think the next thing to do is I'll maybe try 1 or 2 of the acrylics in place and see what happens. But I also have to be aware that I may have to redo some of the wiring if I've got it wrong. So the Vero board, I need to be able to remove it. So, you know, I think I should be okay with that. The acrylic should be able to go through if I pull the board away from the back. So I'll just have to be aware of that when I put it together. And here's the final product. I've managed to use epoxy to glue the buttons in place. What I did was, in the actual push button themselves, I drilled a small 1mm hole, obviously not right the way through, but just enough that the glue would get a little bit of a key, and I've roughed up the underside of the acrylic push buttons with sandpaper, and that gives them a bit of a key as well, and just a spot of epoxy, not enough that would drip down the sides of the push button there. Seems to have held them in place pretty well. So I can turn the unit on. There we go, and hit some of the buttons. There's the units, the min max. Everything seems to be working fine. Like I said before, I do have one of these rubberized keypads coming from the States, so I probably will change it out when I receive it, because I mean, it does look rather awful, doesn't it, really? Black's not the best colour, and the Dymo labels that I've managed to print to fit on the top there, you know, it does look a bit Heath Robinson, but it's a functional unit now. For a unit I bought off of eBay for, you know, £17 I think it was, it seems to be working great. You know, I've got a thermocouple attached, it seems to be working fine, so it's another tool for the workshop. It's certainly a better thermometer, digital thermometer, than I've got already. It's a nice fast display. You know, if I take the thermocouple here, it's, you know, it's real fast there. So, you know, my other ones are a lot slower, so it seems to be working just fine. So another tool for the workshop. So thanks for watching.